Thanks for coming. I don't know if you know us. We're Arize AI. We're one of the leaders in observability and evaluation. Today we're going to be talking about evals, but also a lot about agents. Agents are kind of the top of what every one of our customers is actually working on these days. I'm seeing incredible products built with them. But a lot of those products don't work when you just first build them in the first POCs, the first proof of concepts. So making it work is really the hard thing. And today we're going to be telling you a little bit about how it is to make how you make these work. A little more about us. I don't know if how many of you know us, but we have we're kind of one of the largest in this vertical. We have some amazing customers that range from the bookings and Pricelines, the Ubers, the Spotifys. To large enterprises like Pepsi or Lowe's. And so every single one of these customers is trying to use AI these days, AI and agents being more complicated execution to really go automate stuff in their business or build these amazing new competitive products. Today I'm kind of going first here, but we have an awesome set of speakers. From Google. Thank you, Google, for hosting us. Amazing AI products that they're putting out right now. A little bit about evaluating agents from our team, and then a panel where we'll talk to people actually deploying this stuff. So observability and evaluation is really one of the, I would say, the most challenging areas in trying to make AI agents work. And it's this combination of both collecting what your systems are doing and evaluating them using AI. And so evaluation is this really fancy, hypey word, which really is about using AI to come up with performance metrics about your system, and combining those two together to really make the thing do what you want it to do, which is where hard engineering comes into play, and it's kind of what the big challenge is. And we'll show you a bit of demo in addition to just showing you kind of a little bit of what we recommend from a use case perspective. So the hardest thing about this is kind of making AI work, and what we do is we work from agents to traditional CV to co-pilots, you name it. We see customers building it, and our tools are used from early stage development. So as you're iterating on your prompts or iterating on the AI you're building, to tracing those frameworks that you're building with, to actually putting it into production. Our tools kind of work across the whole suite, and we have some tools for even earlier in cycle. So if you're, Phoenix, which is an open source solution that we support out there, is also used in the kind of very, very earliest stages as you're building and iterating. So what goes on, and what is the modern platform to help you make AI work look like? Well, you're gonna get a demo of this, but basically it's a piece of software with data as this foundational rail that helps you improve and build the systems from development to production. So in production, you might annotate your data, have a human come in and tell you what cases are good or bad. And you might use that data set you've annotated in your development workflows to improve the AI you're building. You might build an eval that helps you understand if it's working, what you built, the framework's actually doing what you want. And then you might want to use that eval in production to make sure it's not going off the rails. Instrumentation, so agents and AI, I would say tracing is like an afterthought in software, or was an afterthought, and now everyone does it. But in AI, tracing is what people use in the early building phase. It's because all these frameworks have 100+ distributed system calls underneath. You kind of need tracing and instrumentation to even make them, to even debug the simplest kind of agent system that you build. So instrumentation, you want to use the same instrumentation that you build in development, use it in production. And then a lot of this is also about replaying with kind of this IDE with prompts at the center of it. That's kind of what we see is English is this awesome way in which you can now communicate and control these systems through prompts and prompts variables. But you need to be able to iterate on those, add instructions to those, understand what this prompt you created is doing. So about replaying on Playground. I'll show you a bit of this in practice. So from a tool chain perspective, there's a wealth of frameworks and instrumentations and technologies that people are using. But I would say This is kind of an example and a great suite of things. Obviously, we're highlighting what we do, but you have this whole center set, which is orchestration frameworks. Google just launched about, I think it was about a month ago, the Agent Frame Kit at Google Next. Awesome framework to build agents in, again, more complicated AI systems. But we support whatever you want to choose. We're the independent player in the platform space. So whether you're building with Agent Frame Kit or Crew or Lane Graph, we'll support those. Now, how do you make sure these systems are actually doing what you want? And I guess a question for you all, how many of you know what like evals are, or evaluations are? Okay, wow. I mean, we've come a long way. How many of you actually used and created an LM as a judge eval? Okay, that's a lot. That's awesome. We would ask that question 6 months ago, and it was like a handful of hands in the room. So this stuff has become mainstream. A lot of how you make AI work these days is using AI. Go figure. A little bit meta, but basically, I would say the more popular way in which you're judging these systems is using AI, called LM as a judge. Phoenix had it almost 2 years ago. We had one of the first LM as a judge instrumentations in open source out there. Now it's just common everywhere. But we've been doing this a long time, and we use the same stuff from Phoenix in our main enterprise platform, AX. There's code-based evals, so evals aren't just LLMs judging your system, but you have code-based evals, you have humans as well, annotation-wise. So this is kind of like the trifecta of what people use to make sure these systems work. It's LM as a judge, maybe some code tests on the outside, and then annotations from humans. Obviously, there's other metrics that you use as you put the system into production. So these are kind of the core areas, but platforms like ours have to support. And the challenge of evaluating an agent or a system is that like a single line of code, this is an example of a kind of one of the agent frameworks, has 100+ calls underneath it. So I might be making 50 different LLM calls underneath, or maybe 20, and doing retrievals underneath this. So basically, what used to be pretty simple systems that you can test locally CI/CD wise require a bit of tracing. So you need to understand the call stack, which is happening underneath your framework. This, example of again, agent frameworks would be Google's Frame Kit. You have Lane Graph, you have Crew, you have a number of these link chain from last year, I would say. Every single one of these has this challenge of single line of code, and there's a lot going on underneath. What is it, and then what does it look like underneath? And this is an example of what we see out there as an agent that is maybe used in a chat to purchase type scenario where there's a router LLM. So there's basically an AI that's determining what branch to take. There's something occurring in that branch. I'll take a simple example, which is like someone either asking questions about a product, or searching about a product, or maybe asking for support. So there's an LLM in the front that typically will route that to the right branch to make a decision, and then maybe there's some LLM calls underneath. In this case, the yellow is an LLM call, and you're deciding whether to do product search, track a package, promo detail. So long story short is these are complicated. These systems are getting complicated, and we're using AI, which is complicated in itself. And a lot of the challenge is just making sure it's doing the right thing. And so normally what we will do in these AI systems is start to break these up, like engineering problems, into things we can test. So maybe from a router eval perspective, you might be looking at whether it's routing to the right thing. Are you searching for a product? Did it route to the right APIs to deal with search? Did it route to the right APIs to deal with support? So there's evals that look at like is the LLM router working, and there's execution branch evals which just look at whether that thing's kind of doing what you want. Little taste of what's coming. We have a whole suite of solutions to be able to track and trace and understand the path at which the agents are taking and how they're working. I'm going to show you a bit of demo here, but there's a lot being invested here to make this stuff work, and making it work is half the battle. Cool. Awesome. Cool. So, I guess another show of hands. How many of you have seen kind of like LLM or Gen AI tracing before? Okay. So, I mean, that's good. It's probably the same people who are doing evals or doing tracing too. So what you have here is you have you have an agent traced. And in this case, I'm going to give you an example. In this case, the Arize docs here have kind of an ask question service that helps us ask questions, and we kind of trace and track it. And what I'm going to walk you through here is a little bit of like what Q&A looks like and what it looks like under the hood and how you debug a problem within that system. So from a Q&A perspective, there's a query that comes in. There's a question asked. In this case, it's how do I use the SDK to upload a model into the platform? And underneath this, you have a retrieval that retrieves some context. You have some LLM that synthesizes that and responds back to the user. And in addition, at the top level, you have some evals. You can see 2 have run here that are analyzing and assessing whether this question was correct, whether it got the answer right, and if it's wrong. And so these evals can be a lot of things. In agents, I've seen frustration. Is the user frustrated at the session? Is the user kind of confused? There's a ton of things I've seen to be able to assess the quality of the outcome, which almost sometimes it's like product level, sometimes it's like engineering level. In this case, the eval kind of points me to a problem here. I'll just kind of jump to the point, which is these steps are not mentioned in the reference text. So I've got this long answer here, which is like this 1, 2, 3, 4, 5, 6, but I've just made it up. There's nothing in the reference text, which I'm generating the response on, that kind of tells me that. And so what you have is you have data that comes in, which is a bunch of questions user asking. You have tracing that captures kind of what's internal in that. You have evals, which is AI, looking at whether the stuff is working correctly, like if it's hallucinated or making up incorrect data, incorrect answers. And this, going to what does that look like? What does LM as a judge look like in product? There's evals, and sorry, I'm on my phone Wi-Fi here. There's evals, and there's LM as a judge, as I mentioned. There's code evaluators, and typically these are jobs that run on top of your agent or assistant, and basically it's running something that looks like a prompt on top of your data. So there's pre-built evals, which kind of, in this case, it's a little bit of a prompt saying what you're looking for and what data to look for here. So it's, again, instructing AI how to evaluate your system. You also have AI built in here that helps you write these. So if I want to, create an eval for user frustration, I kind of mentioned that one, and I can spell it wrong too. So I can build these on the fly. It builds a template for me. It knows my data. It knows where to grab things from. So AI will help you construct your performance metrics for your system. In this case, it's user frustration, but I might have hallucination or QA. So as your data is ingested, as you're tracing your frameworks and agents, AI is looking over it. It's augmenting your data with assessments that you then can use with power tools in product to search and discover and find problems. So just back to what this looks like in practice. Those evals that you kind of showed there, you can see these are examples. These hallucinated examples are kind of that job I had, what was on top of the data. So each one of the, and so I can, if I want to filter, so this is AI augmenting my data, and I can filter on it and discover on it. I also have power tools built in here if I want to use AI to search across my data. So find me frustrated, or find me frustrated. questions, maybe something like that. So I can search across my data, I can do things where I use AI to find me frustrated questions or prompt hacks or tell me the top reasons for hallucinations. So big vision we have is AI plays a big part in helping you build AI. I mean, that's another meta thing, which is AI needs to power a lot of the tools that help you scale your analysis and troubleshooting and search and discovery over the systems you're building. So that gives you a bit of an overview. There's an incredible amount more here, like examples. I'll go through one more example. Is if I want to fix a problem, I might hop to a playground with my production data and swap out for maybe Vertex Gemini. So if I found an issue and I wanted to try a different model, I could do it on the fly. I can kind of replay problems. I can replay on data sets I've created, and I can troubleshoot issues or test two prompts side by side. So all these workflows are designed to like work on your data, troubleshoot, improve, iterate, develop, and then debug. Hopefully this gives you an idea. But there's an incredible amount of like analysis and troubleshooting tools that go into making agents work, and this hopefully gives you an idea and a taste of what it looks like. Thank you. Well, the rest of the team here is going to dive deeper, but hopefully this gives you an overview of kind of what we're building today and what our customers are using. Thank you. Before we kind of hand off to the next one or 2 minutes, any questions on kind of what we put up? I'll take one there.
Yeah. Nice presentation. I'm curious about one thing. If
Yeah.
you're using LLM to judge whether there was an hallucination,
Yeah.
does that judge LLM hallucinate, and how do you control that?
Yeah, so evaluating the evaluators. There's a bunch of, I feel like there's a lot written on evaluating the evaluators. A lot of what you do, so the question, just to repeat, is LLM as a judge might make up things or be wrong. It definitely can. So typically what you're doing is you're using human annotations to guard and correct and understand how good your evaluators are. So typically it's humans overseeing the evaluators. And then there's a lot of approaches out there where you can actually improve those evaluators. So add instructions in and kind of tune the evaluators to be better. So good question. I think I think they're not perfect. They're kind of proxies for performance, but they allow you to scale out much more greatly than having humans look at everything. But cool. I'll take one more. The human annotations, actually, I see teams doing surprisingly small amounts of them. I had an example of a team recently who did human labelers and spent a lot of money to go do that, and they did like a quorum of judges or jury of judges and compared those two, and the humans just get tired. So like what we see is people do hundreds of samples maybe of kind of corrections or annotations, but you're not in the traditional ML world. Hundreds would not be enough. You're typically in the thousands, tens of thousands, hundreds of thousands. Where in this space you don't need that much to kind of tune things. So I think I see human annotations in the kind of range of hundreds typically. 100. Cool. Well, Kevin, I'll do one more question and then, yeah.
The LLMs as judges,
Yeah.
Are there any standard data sets on which these were measured against? If so, what are the numbers?
Yeah, so question of LLM as a judge, standard data sets. So in the Phoenix library, we actually do them on there's a bunch of standard eval data sets out there. There's some for hallucinations. I think it's Hello Eval or Hello Eval. We even put out one recently for a really large eval data set for hallucinations detection. So there's a number of them out there, but they would fall in the eval data set category. And grab me after, I could probably point you to some. And so thank you. Kevin's coming up next from Google. Thank you, Google, for amazing AI tools you put out. And awesome.
Thank you. Do we got this on? Oh. Just Do we need these or later? Cool. Well, welcome. Thanks so much, Jason, for having me. And I think thank you, everyone, for coming out here to the Google Chicago office. My name is Kevin Strickland. I help lead our marketplace co-sell motion for retail accounts in Google Cloud, which means for the last 6 years, I've worked with some top ISV and technology partners, such as Arize, to solve some of our customers' toughest problems with Google Cloud solutions, as well as our wider ecosystem. I'm going to spend just a couple minutes here outlining Google Cloud's position around AI and its importance, which you're going to hear a lot of today, but I don't think it can be overstated. We're seeing a huge amount of focus and budget going from companies in all industries across into generative AI to drive their business. This might be recent public interest in the last couple of years, but from a Google Cloud and Google side, this has been decades in the making, even publishing the Transformer architecture back in 2017 that truly drove the back-end concepts that drive much of what we see in Gen AI and LLMs today. So I went and had to ask Gemini, our own next generation multimodal AI, to say, what is Google Cloud? Google Cloud is a comprehensive suite of cloud computing services and infrastructure that leverages Google's global network and AI expertise to help businesses build, deploy, and scale applications and data solutions. We might have gotten a little later start than some of our competitors, but as this chart shows, we're definitely fast risers. As you work and look into the Gartner Magic Quadrant, we continue to be up and to the right, which is truly calling out our ability to continue to grow from both a product maturity standpoint and customer adoption, with large amounts of that being driven through their use of AI. We've seen growth of over 5x in the last 5 years and continue to see more and more. And part of the reason we're seeing that is because we think we're uniquely positioned in the cloud service provider space as the only cloud that offers a full unified stack of enterprise-ready AI tools across the whole spectrum of needs to ensure we're meeting you where you are. Starting from the bottom, we're talking about our AI supercomputer and the Google's own data center and infrastructure, which gives us the scale and efficiencies to drive all AI workloads and training, partially driven by Google's own custom-built TPUs. As we move up the stack, we have models from both our own first-party as well as third-party and open source that can drive a wide variety of needs that then all gets grounded using our industry-leading data services to ensure you have the models running based on your own enterprise data. And helping coordinate that on top of it is Vertex AI, the only integrated AI development platform for rapidly experimenting and scaling models into production before getting to what we see as a wide variety of application layers for my AI tooling, whether it's naturally built into Google Cloud and Workspace, AI agents that Google pre-builds or allows you to build on your own, or then Agent Space, which is our foray into enterprise search for our customers. And if you know anything about Google, we know search. But at the same time, with this stack, we don't do it alone. And what we want to be pushing is to ensure that customers can take the best of what they want across our ecosystem. We have our own TPUs, but at the same time, we work closely with NVIDIA, Intel, and AMD. From a model standpoint, our model garden now has 130 models across some of the leaders in the industry, like Anthropic, AI21, Cohere, as well as our first, that allow you to pick what is the right model for your use case. We then work with a wide subset of technology partners that help you meet you and your developers meet you where we are, and Arize is a great example of this, helping to both build, deploy, and maintain those agents. Our SaaS partners have taken the Google AI solutions and built them into their own products so that their customers are able to natively get additional value as they see these tools they've already been working with. And for those that truly need additional help and growth, our services partners continue to train and develop their skills in the Google AI solutions, and we're now up into the tens of thousands of resources that are certified that can come help you from a strategic implementation all the way to management going forward. It is called Google Cloud Platform, and that's truly because that's what we are. We're a platform, and it's only as good as the partners that we drive alongside. Now with that, and given it is here with Arize, we have to talk agents. 2025 is truly the year of the agent, and we're moving away from AI as truly just a tool, but to a collaborative partner that we're working with alongside. At a basic level, we see it across three things. That agent has to find, understand, and then act on a specific tasks. Google has a wide subset of where we see agents fitting in, but I do want to call out a couple that are just, we're seeing some great uptake, including our customer agents that are driving additional personalization and customer experience, as well as our creative agents that are able to develop creative media marketing content from both a text, image, and now even video standpoint with the recently launched VO. And this isn't just a hypothetical. We've now seen a huge amount of customers that are bringing this into production. At last month's Google Cloud Next, we announced and laid out 601 real-world Gen AI use cases. And you can go ahead and read all of them online. This is up from just 101 just a year later. And we're continuing to see that type of growth. These are just a small subset of logos, but represent a huge diverse set of industries, company sizes, and geos that are all taking advantage of our solutions and putting those into production. Feel free to Google, as you may, 601 real-world Gen AI use cases to understand what some of your partners, competitors, and others in the industry are actually already doing from a Google Cloud standpoint. Taking a look at just one of those examples, I wanted to speak to Wayfair, who is a joint Arize and Google Cloud customer. They recently implemented Gemini AI to do product catalog enrichment to all of their tooling, all of their listings. For those that don't know, Wayfair is a digital retailer that sells furniture and home furnishings, has over 22 million users. So as they worked to actually to drive this catalog enrichment, it was a key driver of not only efficiencies, but also value. They saw a 67% reduction in the amount of time it took to drive that both new and updated listings, but at the same time, they saw an increase in the quality of those listings based on the enrichment that actually led to a noticeable uptick in the conversion rate, which for all retailers is a key driver of revenue. Moving to another example, I want to talk to Volkswagen USA. Volkswagen set out to solve a key problem of many of their users. What is that light that's in my car and how do I fix it? Old ways would have been opening up the glove compartment, flipping through the manual to try and find what to do. Instead, they've launched the My VW app, which through the multimodal capabilities of Vertex AI and Gemini, allows you to quickly ask questions, find the solve, and then react to anything that may be going on in your car. This has led to a great increase in both the customer satisfaction as well as a overall vehicle safety from their side, knowing that their customers are able to quickly find and actually fix a lot of those things that might have been previously let go. At the same time, we're working with VW to drive similar agents internally within their employees and dealerships to help drive better decision-making and data as they're driving sales. And with one last update, one last example, I wanted to point to Snap, which is one of the longest running Google Cloud customers. They took their application, which is already used by hundreds of millions of users, and said, what can we do to enrich that customer experience? And that's where they jumped in with their My AI app. But I've been talking for a while now. I'm going to pass it over to Evan Spiegel, the CEO of Snap, to truly talk about what they're doing.
Google Cloud has been a partner since day one for Snap, since Bobby and I were working in my dad's house, and scaling from the first couple of users, our friends, to now hundreds of millions of people all around the world. My AI is a brilliant best friend, powered by artificial intelligence. It's a chatbot where you can ask general knowledge questions, learn more about the world, and have a fun and friendly conversation. And as we started partnering with Google and experimenting with Gemini's capability, what we found was an unbelievable ability to help people solve their problems based on visual context. My AI is great at answering everyday questions. And now that it's integrated with Gemini, you can just send a snap and ask something like, what's the healthiest snack? see what my AI has to say. It looks like kind bars are the healthiest option. So by partnering with Google, we can leverage the multimodal capability of Gemini to understand what's going on in a snap, even read the caption and reply. Snap's community is distributed all over the world, and that's one of the reasons why Gemini's multilingual capabilities were so exciting to us. We think that this new partnership with Gemini and MyAI allows people to learn so much more about the world and to do it really quickly in the moment. With MyAI powered by Gemini, I can easily practice my French. Translate this to French. Gemini's multilingual capabilities make it really easy to translate text and, of course, learn a new language. Ah, how fit. Google Cloud's flexibility and ability to scale with our business has allowed us to focus on what we love to do, which is innovating for our community. With Google Cloud, Snap is building the new way to stay close with friends and family.
Cool. Yeah, and this is truly because of Gemini's ability to be both multilingual and multimodal, allows for a wide variety of customer experiences to continue to drive forward, and they're continuing to test to see what they can do to drive their users to do more with the MyAI app. From my perspective, the healthy food option would either be a target or something to avoid, depending on how I'm feeling that day. But overall, I truly wanted to finish up just calling out some of the momentum we've been seeing across the Google Cloud side with a couple of key data points. Vertex AI in just the last year has seen a 5x increase in the number of customers, as well as a 20x increase in the amount of users as more and more developers work to the platform to help build alongside the Google Cloud capabilities. That's noted in the fact that 90% of Gen AI unicorns are leveraging Google Cloud, and we're continuing to see and work with more and more of the Gen AI funded startups. Lastly, as we talk to the ecosystem, I want to point out that the Google Cloud Marketplace, which allows you to facilitate the purchase of our third-party ecosystem, is now doing billions of dollars in business, helping to bring the best of Google Cloud to our customers. And as an example of that, I'd like to highlight the Arize team, which is truly allowing us to accelerate and expand what we're doing across the AI space, helping customers build and deploy agents, while at the same time making sure that post-deployment they're able to maintain that quality and reliability going forward. We've already called out a couple of joint customers, but we continue to see more and more traction, and we're excited to see what we can do with Arize going forward through their use of Vertex and sold through our marketplace. With that, before I leave you, one last shameless plug. Google I/O, our annual developer conference, is this week. We've got the keynote tomorrow at noon that is live streamed, as well as a wide variety of events for the rest of the week to get the latest and greatest on everything we're doing AI. With that, let's build.
Cool. Hey, everyone. I'm Sally Ann. There we go. I'm Sally Ann. I'm a staff product manager at Arize. I spend a lot of my day thinking about agents, whether it's our internal agent copilot that helps folks navigate our platform, or talking with customers about how to evaluate these systems, or trying to build workflows. I spend a lot of my day thinking about agents. So I thought for today we could talk a little bit about how we think about developing and evaluating these systems with feedback-driven agent development. So this is kind of the agenda for today. I'm going to talk a little bit about why evaluation matters, talk through challenges, and pretty much present how we think about evaluating these systems and why it really matters. So to start, I always like to begin with what are agents. I feel like these days everybody has a little bit of a different definition, so I'm going to define what I mean when I say agent, which is basically just a system or application that can somewhat autonomously perform tasks on behalf of a user or another system. So a tool is going to be a resource that an agent can access, think like an external API call, and then a skill is going to be essentially like a collection of tools. So just wanted to call that out before we get into it. So want to start with an example of what happens when an agent goes off script. So imagine you have a trip planner agent. It receives a request, book me the cheapest flight from Denver to San Francisco for tomorrow. But the router misclassifies the intent as hotel booking, and now it's triggering the hotel search tool instead of the flight search tool. The agent's going to reply probably with some hotel recommendations, which is completely irrelevant to what the user asked for. And the user is confused. They're probably just going to close out of the application. So imagine, a week later, an engineer goes in and they're like, oh, there was a 35% decrease in our users. What's going on? This is why evaluation matters. So agents are making chains of decisions, and a single wrong step, in the last example, it was that router who misclassified the intent. And there's this no spike in any metric because there's not one metric that can calculate this. So traditional output metrics, like if you look at your error rate or your latency, you're going to miss things like the wrong tool, the wrong reasoning, or any half-done tasks. The evaluation is really the only way to create a structured feedback. So that's why it's super important. And taking this kind of one step further to evaluate to explore the complexity of LM agents. LM agents don't just respond. This is not your simple back and forth chat. They're perceiving, they're deciding, they're acting all based on information that they're getting in. So we have multiple moving parts. Jason kind of called this out in the beginning, that there's routers, there's tool call, memory is a huge part of this, processors, and each and every one of these is a potential failure point. There's also opaque decision making. Failures are really subtle. They're hard to trace sometimes, wrong tool call, incomplete logic, misleading outputs, and that kind of leads to the third point here of fail soft behavior. In that example that I gave, the application didn't error. There was really no indication to an engineer that something went wrong. The user only knew because they were reading a result that had nothing to do with what they asked for. And this is high stake content. I mean, everyone here has probably heard from leadership, let's integrate AI. There's a lot of top down. And whenever there are mistakes, we're hitting money, we're hitting revenue, we're losing trust in our users, and even sometimes safety. Our compliance people can be upset with us. So there's a lot of complexity that we need to track, and that's why evals are super important. So I'd like to propose this kind of systems perspective on evaluation. Jason also hinted on this in the very beginning, but you can't really just evaluate the output of agents. You really need to break these agents' behaviors into discrete steps and think about each of these and understand, was it the right decision? What do I care about at this stage in your application? And you really want to think about it like debugging a program. Inputs, reasoning path, outputs. It's not just one step that we're going to think about. And so I'll have a visual of what this looks like in an application, but let's talk about what success is and how we think about defining success, which I will say is probably the most important part of your agent. I meet with a lot of teams who think that they can just pull something maybe off the shelf or just throw on one eval and set it and forget it. That's definitely not the case. Because evals are our lens into performance, we don't want to just check accuracy. We want to talk about decision correctness, those tool usage patterns, any reasoning coherence, and then the final output quality. That's important too. You want to make sure that you don't have a super verbose answer or the output is in an inappropriate tone, things like that. So each point in the agent path should be evaluated. And then you can use these evals to spot weak points in your application for improvement. And so that's going to be the key idea here. So an example of that, is this. So this is a very simple agent. You can imagine as you have multi-agent systems where there's multiple routers, the complexity increases. But this is an example here of how at each step of these, we have questions that we can ask ourselves. So of course we want to know, did the agent do what it should? But before we can even begin to answer that, we need to look at each step. At the question, was this a jailbreak? Do I even have an eval for things is it in scope or is it toxic? At the router level, we might care is it the right function? Did the function get correct arguments? And then so on and so forth till we get to the answer and then understand, is it correct? Is it concise? And then we can determine whether or not the agent did what it should do. So at each and every point, there's an eval that should be written, a lot of times multiple. So with that is this idea of feedback-driven development. And so you don't really need a fancy system. You just really need to structure your thinking around defining your criteria. Again, probably the most important part. Get all your stakeholders in a room, decide what everybody cares about, and then start equating those, translating them into LM as a judge, as code evals to make sure that we have coverage at each and every one of those points. We'll run those evaluations, and then what we can do from there is actually collect those failures. Now we know where things are going wrong. We know where the answer is incorrect. We know where the tool choice was incorrect. We can start collecting those failures into the data set and then review those with your subject matter experts. And the subject matter experts are going to look a little bit different depending on what you're evaluating. Something like me from product, we care a lot about the user experience. We want to make sure that the user is getting the answer that they want. We want to make sure that it's sticking to like our company guidelines, making things look good. But the AI engineer might care about something else, and your safety and compliance officers, they might care about something else. So you want to review those failures so you can understand what the agent should have done. And then you can use that as information to update the agent based on what went wrong. Instead of just sitting, trying to iterate with kind of this black box approach, when you use feedback from your evals, you can actually be really targeted and go after the things that matter, the things that are impacting you the most, and then you have data for exactly how to fix it. And this is pretty scalable. So once you have your evaluation criteria, you can kind of run these at scale. Like at Arize, we run online tasks. You can have continuous coverage over your data. And then we're automatically getting those failures tagged, and we can even automatically add those to a data set, and you can use our platform to annotate them too. So eventually you kind of move towards this like automated improvement, and you can even move towards automating things like prompt optimization. And all of this is really borrowing from self-driving. So if anybody's familiar with the self-driving space, this is very similar. Think like them. You're not building a static app, as Jason pointed out. We're really building a system. And so we need to borrow that mindset of treating errors as our training data, capture these failure cases, and then use humans in the loop. I know everybody wants to automate things, and I do see a future in which LLMs are kind of running themselves, but I think we're far away from that. And so you definitely want to make sure you have humans in the loop. Not only reviewing your evals and improving your system, but your evals are also something that also should evolve, and you should have people working towards improving those as well. So measure, test, retrain, reevaluate. That's kind of the theme here with this feedback-driven approach. So covered a little bit, but some takeaways that I'd love everybody to keep in mind is evaluation is the engine of continuous improvement. You can't improve what you don't measure. So that's why you need evals, so that you know exactly what it is that you should be improving on. Focus on the agent decision, just not the outputs. Your output is going to be related to those decisions. So if you just look at your output and you say, oh, that's bad, you're not going to know why until you evaluate each of those decision points and understand how they went wrong. Structure your process, define, test, learn, improve. Think of loops. It's not just one-off. This is kind of a continuous cycle that you'll return to again and again. That line between development and production is a lot more blurred in these agents or in LLMs in general than it was in like our traditional ML days. Treat agents and evals as co-evolving systems. I didn't quite hit on this that much, but I think this is a really involving thing, that evaluation criteria should grow with your agent's complexity. Again, don't just pick something off the shelf and set it and forget it. As you collect kind of failures of your agent, you should also be thinking about where your eval is failing and involving that as well. Start scrappy, scale smart. You don't need automation on one day, but you should be thinking about your evals and using that system-like thinking. And then lastly, use your failures as fuels. They're not setbacks. Things are going to go wrong. This area is really evolving. Nobody quite knows what they're doing. But if you use those failures in a smart way, they're technically your kind of like training data in this new world. So that's it for me. Any questions? No? Question? Yeah?
I have a question
Yeah.
in relation to the database potential things that went wrong
Mm.
in testing.
Yeah.
And like you said, you need to use those to learn. Do you have something to start with that you've already learned and tested and have built on that
Yes, you're talking about, the question was like with a data set of failures, is there one that like Arize has that you can kind of build on? We have like data sets that you can use, but I think in this specific example that I'm talking about, you're going to want it to be specific to your application. You're going to want to identify areas where your application is going wrong so that you can kind of fine tune that for your prompt. Because we're talking about different prompts and different systems, it would be hard to kind of use the same data set. When you're talking about something like fine tuning, maybe there's data sets that you can use for that, but in this specific context, it would be application specific. Makes sense?
It does, but I'm more in relation to like the general LLMs that we normally use, everybody would use.
Mm-hmm.
Is there any biases in those that you can identify and
So you're talking about like in the pre-training kind of steps? Yeah, I think that, I'm sure there are known data sets of like that you can use for like benchmarking and things like that, but I don't, again, in this context, I'm talking about like improving specific prompts. So it's like slightly different there. Yeah.
From a product perspective, what have you seen be like one of the most business impactful ways to evaluate these data sets and techniques that you've seen?
Yeah, I think that the most popular is definitely making sure you're evaluating at each and every step and making sure you have your stakeholders when you're defining criteria. I've definitely worked with customers where maybe like AIN has set like some criteria and then maybe like a week later like product has some and then like a month later like security comes to us and says like, well, are we paying attention to like jailbreaks or toxicity? How do we know we're not like mentioning like competitors? So I think that that's something is like making sure you have like buy-in from everybody who has an opinion really, and then that evaluation at every step is also really important, and it is very easy to succeed when you have kind of visibility into each step versus something breaking and then being no insight into it.
So that's, if I summarize, is that like collective goal setting?
Yeah, collective goal setting is a great way to put it. Yeah. Yeah.
So I was thinking, you talked a little bit about tone. So I was also wondering, in cases where it's not that structured, the output. So say I'm building a character, right? And I have 100 different characters, right? And let's say I have Gandhi, for example. Gandhi can talk about anything, but he cannot be aggressive, or something like that, where it's just not that defined.
Yeah.
How do you measure that?
Yeah, so the question was is like you have a bunch of different characters, a bunch of different acceptable tones. How do I put that into an eval? Is that kind of correct? I think you're going to want to probably use multiple evals is how I think about it, and you would probably have an eval specific to like each of those. What we do know about LMs, if you try to overload one task with like a lot of different information and make it almost do like a classification step before evaluating, it could struggle a little bit. So I would almost think about it as like maybe having some kind of label, not maybe an LM as a judge in terms of evaluation, but some kind of label that says like what the character should have been that it takes, and then evaluate whether or not it was successful at embodying that character. That's how I would think about it. Yeah, one more question, then I think I have to get off.
So curious, I mean, agents are obviously becoming popular, but
Yeah.
a lot of use cases you can do without agents. You
Yeah.
can call multiple LLM multiple
Mhm.
times, but a lot of people are transitioning those use cases to using agents.
Yeah.
So do you see any cons at this point, or do you think agents are mature enough where they can like control the flow where you could like easily do it with the software?
Yeah, I think that it depends. I definitely see folks adding a lot of complexity where there shouldn't be. I don't know if there's really a concern of like, could an agent do it? Probably, but there's a lot of complexity that you would then have to manage. You have to evaluate. You have to understand where you don't need to. So I usually recommend users kind of like map it out. And if you don't really think you need this complex flow, then don't. Keep it simple, because you're going to get better performance and it's going to give you like a lot less of a headache. I feel the same way about like reasoning models and regular models. It's like I feel like a lot of folks reach for reasoning models, but you don't always need that complexity. You can end up hurting yourself. So I'd say the same thing for whether or not you need an agent framework. All right, cool. I'm going to get off in just 1 second before I do. These are some slides that we did on the beginning, but if you do try out Phoenix, please leave us a star. Let us know that we're doing something right. But more importantly, I want to invite everybody here to our conference in San Francisco, Observe, happening in just a little over a month. A lot of great speakers are going to be there. I'll be there. And it's just like going to be an awesome community event. So June 25th, you can use this promo code if you want to get a $50 ticket, which is quite a savings.